Hello dear students, today we are here with a new chapter, name is Chemical Kinetics. It is a very important chapter, at the same time it is very easy too. Okay. So, when we consider any type of chemical reaction, three things that comes in our mind. Which are the three things? Okay. First one is about the feasibility of the reaction. Okay. First thing is about the feasibility of the reaction, and the second thing is about the rate of the reaction, that is what we call rate or speed of the reaction. Then third thing is the extent to which the reaction proceeds, the extent. Okay. So, these are the main important three things which comes in our mind when we heard about any chemical reaction. Okay. And the first question is about the feasibility, which tells us the answer of this feasibility tells us the unit thermodynamics, which you are going to study in your upcoming chapters. Okay. So, the feasibility will explain by thermodynamics. It is another branch of chemistry which you are going to study. And the third thing is the extent of the reaction. The answer of this question will give you the chapter Chemical Equilibrium. Chemical Equilibrium. That also you are going to study in your upcoming units. Okay. And what is the second thing? About the speed or rate of the reaction, or how far the reaction happens. That is the thing we are going to study in the chapter Chemical Kinetics. Okay. Along with this feasibility and extent, it is equally important to know the rate also. In our daily life we can take one example. Which factor determines how often the food gets spoiled? How far the good food gets spoiled? Suppose when you are buying vegetables, when you keep it in outside, it will get spoiled more easily. Otherwise, when you keep it in refrigerator, what will happen? The food remains without spoiling some more days, isn't it? You examine, you notice the changes, right? Then why it happens? That is, spoiling of food is a type of chemical reaction. When you take outside or keep it in outside, what will happen? It gets spoiled more easily. So, there the rate of the reaction will be fast. When you keep it in refrigerator, what will happen? The spoiling rate will be slow. That means while applying some reaction condition, the extent or the rate of the reaction will be changes. Okay. So, like that example you can see in your daily life. Okay. For example, when you traveling in a vehicle, how far the fuel gets burned, that also determines the rate of the particular chemical reaction. Such type of reactions are lots of reactions you can see in your daily life. Okay. So, we will study the extent or speed of this type of reaction. Okay. So, that branch of chemistry which deals with the reaction rates and the factors which affects the rate of the reaction and their mechanism, that branch is known as chemical kinetics. So, what is chemical kinetics? It is a branch of chemistry which deals with the rate of reaction, or we can say rate means speed. So, rate of reaction or speed of the reaction, and also the factors which affects the reaction rate, the factors which affect the rate, and the third thing is the reaction mechanisms, So, chemical kinetics is defined as the branch of chemistry which deals with the speed or rate of the reaction and the factors which affect the rate and also the reaction mechanism is known as chemical kinetics. Okay. So, in this chapter mainly we have to study these topics. Which are they? Firstly, we have to study what is meant by rate of the reaction. And the second thing is, just now I told you, factors which affects the rate of the reaction. Which are the different factors? First one, temperature, then pressure, concentration, catalyst. Okay, so in the effect of concentration we have further discussion, that is about rate law and order, and such terms we have to study. And then next term, molecularity, then theories of reaction and their mechanism. These are the simple outview of this unit, chemical kinetics. First we will discuss about rate of the reaction. What is mean by rate or speed of the reaction? Suppose we are taking an RB flask which contain a reactant A. We are having n number of reactant molecules, a reactant molecule. Okay, so we are, after proceeding a reaction, the A molecules can be converted into B. Suppose B is the product and it is converted into completely into B, അല്ലെങ്കിൽ we can say product molecule. Okay, so product molecule. Okay, so you take a reactant in an RB flask and you proceed the reaction at the time t equal to 0, that is at the initial time when you are starting the reaction. What is happening? That at the starting time the complete will be the reactant molecules only. Okay, and RB flask contain A molecules only. And after proceeding the reaction, the A converted into product molecule. After the completion, suppose at a time t, what will happen? The complete reactant became the product. Okay, so suppose you are expressing the speed or rate of this reaction. How will you express? You have both parameters here, which are the reactant A and the product B. So you can say the rate in terms of both reactants or products. So while proceeding the reaction, what is happening here? That is, reactant molecule goes on decreasing and the product molecules goes on increasing. Finally we have the product molecules only. Reactant is complete, react ചെയ്ത് തീർന്നു പോയി. Okay, so you are proceeding like this. Suppose I am writing like this, A gives the product T and the rate R is equal to what, in terms of reactant or in terms of product you can write. Okay, so I can write like this, rate R is equal to increase in, so first in terms of reactant we can write, that is decrease in concentration of reactant with time. That is what we call rate. Okay, because the reactant molecule goes on decreasing while proceeding the reaction. That's why I am telling decrease in concentration of reactant with respect to time. Okay, so that we can write like this. Suppose you are having usually concentration represented using a square bracket. So this is mean by concentration of A. Okay, so let A0 be the initial concentration, and after 5 seconds, after 5 seconds A1, let it be A1, then after 5 seconds let it be A2. So change in concentration, how will you write? A2 minus A1, and corresponding time interval also you have to take 0 time, I told you 5 seconds. Okay, so after 5 seconds the change in concentration will be A2 minus A1. So you can write like this, delta A. Delta A means this A2 minus A1. After that particular time interval, what is the change in concentration? I am putting a negative sign here. Why I am putting a negative sign? I told you here we are taking decrease in concentration. For showing that decrease, I am putting a negative sign here. Okay, divided by delta T. Delta T means the difference in time also. Here we are taking initially 0 time. That's why the difference is 5 minus 0, 5 itself. Okay, so that depends upon the time you have to take. Okay, So that is what we call rate of reaction in terms of reactants. And at the same time we can express the rate in terms of product also. What will be the rate in terms of products? Okay. So rate R is equal to, in the product molecule, while proceeding the reaction, product molecules goes on increases. So you can write like this: increase in concentration of product with respect to time. Product with respect to time. നേരത്തെ നമ്മൾ റിയാക്ടൻ്റെ കേസിൽ എന്തായിരുന്നു പറഞ്ഞത്? Decrease in concentration of reactant with respect to time. അപ്പോൾ നമ്മൾ അവിടെ ഒരു നെഗറ്റീവ് സൈൻ ഇട്ടിരുന്നു. എന്തുകൊണ്ട്? ഡിക്രീസ് ആയതുകൊണ്ട്. ഓക്കെ, ഹിയർ we have increase in concentration of product with respect to time. So there is no need for putting any negative sign. Instead of, we have to put positive sign. Okay, positive sign ഇട്ടില്ലെങ്കിലും പോസിറ്റീവ് ആണ് നിങ്ങൾക്ക് അറിയാം, but for clarification I am putting a positive sign here. Okay, so delta P divided by delta T. So this is the rate in terms of product, and also rate in terms of reactant is delta A divided by delta T. So that's all about the rate of reaction in terms of reactant and product. So this is the way we are expressing the rate or speed of the reaction. So I told you rate can be expressed in two terms, that is in terms of reactants and also in terms of products. So that rate is known as average rate because we are taking a large time interval. Okay, so average rate, we can say like average rate of the reaction. So average rate is equal to minus delta A by delta T or delta P by delta T. For this reaction, A gives products. So by seeing this reaction, this hypothetical reaction, you can see that 1 mole of A reacted to give 1 mole of product molecule. Okay, for example, you see this reaction, Hg liquid plus Cl2 gas gives HgCl2 solid. Here also 1 mole of each of the 1 mole reactant reacted to give 1 mole of the product. Here how will you express the rate? Rate R is equal to average rate. R is equal to delta minus delta concentration of Hg divided by delta T. That is equal to what? Minus delta concentration of Cl2 divided by delta T. That is equal to plus, next product terms. So plus delta HgCl2 divided by delta T. So this is the way we express the rate in the first reaction, in the case of first reaction. Okay, so now you look at the second reaction, that is 2Hi gives H2 plus I2. What is happening here? Here 2 molecules of Hi reacted to give 1 molecule of hydrogen and 1 molecule of iodine. So here one problem is there. The stoichiometry is different in reactants and in products. So while writing the rate here, you have to divide that stoichiometric number with the rate. So for example, we will write, how will you express the rate here? That is R is equal to, I will write here, R is equal to minus average rate R is equal to minus delta Hi by delta T into 1 by 2. Why I am using 1 by 2 here? Because 2 Hi molecule reacting here. So what is the stoichiometric number we are using here? You have to divide that number with the rate. So that here minus 1 by 2 into delta Hi divided by delta T, and that is equal to what in terms of product? Same, plus delta H2 divided by delta T, that is equal to delta I2 divided by delta T. Okay, so generally we can write like this. For a hypothetical reaction, AA plus BB gives CC DD. Suppose this is a reaction. Here small letter A, B, C, D represents the number of stoichiometry, I mean the number of molecules reacting or forming. We can say the stoichiometric constants, coefficients. Okay. So here rate R is equal to what? Minus 1 by A delta A by delta T. That is equal to minus 1 by B delta A divided by delta T, and that is equal to 1 by C. Here there is no need for negative sign, okay, because these are the products. So 1 by C delta C divided by delta T, that is equal to 1 by D delta D divided by delta T. So this is the way you are expressing the rate of the reaction, which having the stoichiometric coefficient. Okay. So this is the general form of expressing the rate. Okay. Next we will move to average. Next we will move to instantaneous rate. What is the word? Instantaneous. Instantaneous rate means rate can be expressed in small interval of time. That is infinitesimally small interval of time we can express the rate. That is known as instantaneous rate. How will you express this? You see, suppose you see here, suppose we are plotting a graph time versus concentration of reactant. Okay. So we are conducting a reaction, and with a different time we are noting the concentration of the reactant. Suppose at 0 time the concentration will be 0, and as the reaction proceeds, you know, the concentration of reactants decreases, that I shown in this graph. Okay. So this goes on decreases, and after a maximum time the level will be minimum. Okay. So in this graph, suppose you have to find out the rate at a particular point, means suppose you have to find out the rate at this point, then this is known as, that rate is known as this instantaneous rate. Okay. So how will you find out the rate at a particular point? Suppose you draw a tangent at that point. Any curve you can draw a tangent, that you studied in your mathematics, right? So for a curve you can draw tangent. So when you draw a tangent at a particular point, first of all you draw tangent at the point at which you have to find out the rate. Then you draw slope. Then you find out the slope of the line. Then that slope will give you the rate of the reaction at that particular point. This is the way you have to calculate the rate for an instantaneous reaction. Or mathematically you can represent like this, that is, for a reaction A gives product, you can represent like this, minus dA by dt. നേരത്തെ നമ്മൾ ഡെൽറ്റ യൂസ് ചെയ്തത് എന്തിനായിരുന്നു? ലാർജ് ഇൻ്റർവെൽ ആയിരുന്നു. ദാറ്റ് ഈസ് വാട്ട് വി കോൾ ആവറേജ് റേറ്റ്. ഹിയർ ഇൻഫിനിറ്റ്സ്മിലി സ്മോൾ ടൈം ഇൻ്റർവെൽ വി ആർ യൂസിങ് ഡി. ഓക്കെ, ദാറ്റ് ഈസ് ഡെൽറ്റ ടി ടെൻസ് ടു 0 ആണ്. സോ യു ആർ യൂസിങ് ഡി, that is minus dA by dt. Okay, in terms of reactants, in terms of products, what is that? dP by dt plus dP by dt. How will you find out the instantaneous rate? By plotting graph versus time versus concentration of reactants, or you can plot like this also, because in terms of products the graph will be like this. You know, product concentration is goes on increasing, that's why I draw like this. The curve will be like this only. In terms of reactants, the curve will be like this. Here also you can take any point. Suppose this is the particular time you have to find out the rate, then you have to draw a tangent at that point and find out the slope. That slope will give you the rate of the reaction, the rate at that particular point. So we can represent like this. What is that? A gives P. For a reaction A gives the products, that is minus dA by dt, or that is equal to dP by dt. Okay. Then How will you represent the instantaneous rate for the reaction? This reaction, hypothetical reaction, A giving A plus BB gives CC plus BD. Like the same way, instead of delta, you have to use D here. Okay, so that's the only difference here. So that is minus 1 by A into dA by dt, that is equal to minus 1 by B dB by dt, and that is equal to 1 by C dC by dt, and that's equal to 1 by D dd by dt. Okay, so this is the way you have to represent the average rate of the reaction. Okay, now we will go for a problem. Okay, you look at this problem. The decomposition of N2O5 in CCl4 at 318 Kelvin has been studied by monitoring the concentration of N2O5. Okay, in solution. Initial concentration they are given, and after 184 minutes it is reduced to 2.08 moles per liter. And we have to calculate the average rate and what is the rate of the production of NO2. That is the question they asked, and they also given the reaction also. So how will you find out? Okay, so now we know the initial concentration of N2O5, that is equal to 2.33 moles per liter. Okay, and after time 184, initial concentration means time 0 on the samayirikkum. Okay, and after time 184 minute, what is the concentration? That we can call as final concentration. So concentration of N2O5 at that time is equal to 2.08 moles per liter. Okay, and the reaction proceeding, then calculate the rate. I told you. How will you find out the average rate? Average rate. By seeing the equation, you can express the rate in terms of reactant, also in terms of product. But they given the reactant concentration here. Okay, so you can take the in terms of reactant, that is minus 1 by 2. Here 2 is here, less stoichiometric coefficient. So minus 1 by 2 delta N2O5 divided by delta T. Okay, so that is equal to what? Minus 1 by 2 into delta means I told you the change in concentration. Here what is the concentration? Final 2.08 minus 2.33. Okay, 2.08 minus 2.33 divided by delta T. So delta T, you know, initially 0 time, then 184 minutes. So 184 minus 0 means 184 itself. So what is the value? By calculating this value you will get, so the simple mathematical calculation, after calculating you will get 6.79 into 10 raised to minus 4 moles per liter per minute, because the time is given in minute. So you have to get the answer in this unit. Okay. So 6.79 into 10 raised to minus 4 moles per liter per minute. Okay. So how will you find out the unit of rate constant? Sorry, unit of rate. You know, rate is equal to what? Change in concentration. Change in concentration. Change in concentration divided by time. Change in time. So you know, concentration we usually expressed in moles per liter. Okay, moles per liter അല്ലെങ്കിൽ moles per decimeter cube. Okay, so ഏത് യൂണിറ്റ് ആ തന്നത് അതിനനുസരിച്ച് നമ്മൾ എടുക്കാം. സപ്പോസ് മോൾസ് പെർ ലിറ്റർ ആണെന്ന് വിചാരിക്കാം, ഡിവൈഡഡ് ബൈ ടൈം. സോ ഇവിടെ ടൈം മേ ബി സെക്കൻഡ്, മിനിറ്റ്, അവർ ഏത് യൂണിറ്റിൽ വേണമെങ്കിലും തരാം അല്ലേ. സോ ഡിവൈഡഡ് ബൈ സപ്പോസ് സെക്കൻഡ്. So what is the unit of the rate? Moles per liter per second. So this is the way you find out the unit. So that's why I wrote here like this, moles per liter per minute. Here they given the time in minutes. So 184 minutes means minute inverse. Suppose they are asking the question, you have to answer in moles per liter per second, means what you have to do? You know, 1 minute is equal to what? 1 minute is equal to 60 seconds. Okay. Then you have to multiply this with 60. എന്തുകൊണ്ട് multiply ചെയ്യുന്നത് 184 നമ്മൾ എന്ത് 184 minute 1 minute 60 second ആണെങ്കിൽ 184 minutes is equal to what? 184 into 60. So here 184 into 60. അപ്പോൾ ഈ കിട്ടിയ ആൻസറിന് divided by 60 ചെയ്യണം. So that is equal to ചെയ്യുമ്പോൾ നിങ്ങൾക്ക് കിട്ടും 4.07 into 10 raised to minus 2 moles per liter per second. Okay. Suppose they are asking the question in terms of moles per liter per hour. Then what you have to do? You know, 60 minutes and 1 hour. 60 minutes is equal to 1 hour. അല്ലെങ്കിൽ 1 minute is equal to 1 by 60 hour. 1 minute is equal to 1 by 60 hour. So 184 minutes means what? 184 divided by 60 hour. So instead of multiplying you have to divide. So 184 divided by 60 hour varum. So നമ്മൾ മാത്തമാറ്റിക്സ് ഇത് ചെയ്യുമ്പോൾ into 60 വരും അല്ലേ? So what is the answer? So sorry, divided by 60 varum. So 184 divided by 60. Okay, so 180 into 1 by 60 like that. നമ്മൾ നേരത്തെ കണ്ടുപിടിച്ച ആൻസറിനോട് എന്ത് ചെയ്യുക? 60 കൊണ്ട് ഡിവൈഡ് ചെയ്യാം. So answer is what? 1.13 into 10 raised to minus 5 moles per liter per second. So this is the rate of the reaction. Okay, so clear? എന്താ നമ്മൾ ചെയ്തത്? First they given the equation. So rate equation, you know, average rate is equal to, in terms of reactant you wrote minus 1 by 2 delta N2O5 divided by delta T. Then they given the value of initial and final concentration. So simply you put the values here. Then first you will get the answer in terms of moles per liter per minute. Suppose they are asking the question in the unit moles per liter per hour. Then what do you have to do? They given the time in 184 minutes. So you have to convert the minutes into hour. How will you convert? You know, 60 minutes is equal to 1 hour. So 1 minute 1 by 60 hour. That means 184 minutes is equal to 184 by, divided by 60 hours. So simply 184 divided by 60. അല്ലേ? അപ്പോൾ ഇവിടേക്ക് വരുമ്പോൾ into 60 ആവും. So this answer into 60. That you will get 4.07 into 10 raised to minus 2 moles per liter per hour. Suppose they are asking the question in terms of moles per liter per second, means what you have to do? Okay, in this particular problem I am discussing both 3 units. Okay, so listen carefully. So when they ask in second, what you have to do? You know, 1 second is equal to, sorry, 1 minute is equal to 60 seconds. So 184 minute means 184 into 60. സെക്കൻഡിലാണെങ്കിൽ 184 into 60. So നമ്മൾക്ക് നേരത്തെ കിട്ടിയ ആൻസറിനെ divided by 60. So this is the answer you will get. 1.13 into 10 raised to minus 5 moles per liter per second. So this is the simple problem. This is the way you have to do more problems. Okay, so number of problems you have to do, you work from your home. Okay, so I think you clear with this problem. Okay, so then one more question they asked, we have to find out the concentration of NO2, sorry, rate of formation of NO2 also. Okay, so they ask the question, the rate of production of NO2 also. Okay, So from this you can calculate the rate of production of NO2. You know, rate of average rate is equal to minus 1 by 2 d N2O5, sorry d alla, delta N2O5 divided by delta T, that is equal to 1 by 4 plus 1 by 4 into d delta NO2 divided by delta T, that is equal to delta O2 divided by delta T, and no need for that because they asked the question the NO2, rate of formation of NO2. So you know this value, what is that? 6.79 into 10 raised to minus 4. So 6.79 into 10 raised to minus 4 ആണ് rate നമുക്കറിയാം. That is equal to 1 by 4 into delta NO2 by delta T. So you have to find out this only. Okay. So into 4 ചെയ്യുമ്പോൾ നമുക്ക് എന്ത് കിട്ടും? Delta NO2 divided by delta T. So this is what they are asked. So rate of formation of NO2 means 4 into rate of the reaction. Doing this you will get the answer. So this is the way you have to do this problem. Okay, I think you are all clear. Okay. Now we will do one more problem. So you look at this problem. 2A plus B gives 3C. So this is the reaction they are given, and the rate of appearance of C also given. What is that? 1.3 into 10 raised to minus 4 moles per liter per second. And they ask we have to calculate the rate of the reaction and also the rate of disappearance of A. Okay. So rate of the reaction, what is the rate? You know, by seeing the equation you can write the rate, that is 1 minus 1 by 2 dA by dt, that is equal to minus dB by dt, and that is equal to plus 1 by 3 dC by dt. So you have to find out rate of the reaction. So given term is C here, rate of appearance of C aanu thannittullathu, that is dC by dt. Rate of appearance of C means dC by dt directly they are given. Okay. So what is the rate? Plus 1 by 3 into dC by dt, value is 1.3 into 10 raised to minus 4. Okay. By doing the calculation you will get 4.33 into 10 raised to minus 5. What is the unit? Moles per liter per second. So they are already given the unit, moles per liter per second. So next question they ask what? Rate of disappearance of A. Okay. So you have to calculate dA by dt. Rate of disappearance of A. Why they asked disappearance? Because this is the reactant. So reactant usually disappear. Okay. Here appearance of C means C is the product here. So it will appear while proceeding the reaction. Here they ask rate of disappearance of A. That means dA by dt you have to calculate. So what about dA by dt? You know, minus 1 by 2 dA by dt is equal to what? 4.33 into 10 raised to minus 5. Okay. Or you can write like this, that also you know, or you can write like this, minus 1 by 2 dA by dt is equal to what? 1 by 3 dC by dt. Okay. dC by dt you know. Okay. So dA by dt is equal to, I am not using negative sign here. They already asked the question like this, rate of disappearance of A. Okay, I already told you why we are using this negative sign, because disappearance അല്ലെങ്കിൽ ഡിക്രീസിന് കാണിക്കാനാണ് നമ്മൾ നെഗറ്റീവ് സൈൻ യൂസ് ചെയ്തത്. ഇവിടെ ഓൾറെഡി ഡിസപ്പിയറൻസ് ആണ് ചോദിച്ചിരിക്കുന്നത്, അപ്പോൾ നമ്മൾ നെഗറ്റീവിൻ്റെ ആവശ്യമില്ല. ഡി എ ബൈ ഡി ടി അണ്ടർസ്റ്റുഡ് ആണ് ഡിസപ്പിയറൻസ് ഓഫ് എ ആണെന്ന്. ഓക്കെ. സോ ഡി എ ബൈ ഡി ടി നെഗറ്റീവ് അവിടെ മൈൻഡ് ചെയ്യാത്തത് അതുകൊണ്ടാണ്. സോ ഡി എ ബൈ ഡി ടി ഈസ് ഈക്വൽ ടു വാട്ട്? ഈ 2നെ നമ്മൾ ഇവിടെ കൊണ്ടുപോയി മൾട്ടിപ്ലൈ ചെയ്യണം. സിമ്പിൾ മാത്തമാറ്റിക്കൽ അറേഞ്ച്മെൻറ്റ്. 1 by 2 dA by dt is equal to 1 by 3 dC by dt means dt ആണെങ്കിൽ dA by dt is equal to what? 2 by 3 dC by dt. Okay, so 2 by 3 dC by dt. So rate of disappearance of A is equal to what? 2 by 3 dC by dt. So simply you can do 2 by 3 into dC by dt they given, that is 1.3 into 10 raised to minus 4 moles per liter per second. By doing the calculation you will get like this, 8.66 into 10 raised to minus 5 moles per liter per second. Okay, so this is a very simple problem, and similar problem you have to work out from your home. Okay, so what is the question here? 2A plus B gives 3C, given the rate of appearance of C, and you have to find out the rate of the reaction and also the rate of disappearance of A. Rate of reaction, how will you find out? You know the equation, just now we studied. By using that equation you find out the rate of the reaction in terms of C. Why we used in terms of C here? Because the given term is C here. Okay, then after finding out the rate, next you have to calculate the rate of disappearance of A. Okay, so by comparing these two you can simply find out the rate of disappearance of A also. Okay, so that's all for today. So we discussed about the rate of the reaction and what is mean by average rate, instantaneous rate. Okay, then how will you find out the rate of reaction for a instantaneous rate? Okay, then next class we will discuss more about the factors affecting the rate of the reaction. So thank you.